So students, we already completed part 1 for your potentiometer concept. Today we will discuss part 2, and in part 2 we will discuss the application of potentiometer. In your book there are 2 application of potentiometer which is very important for your board exam. Application number 1, with the help of potentiometer we can compare the EMF of 2 primary cells. And application number 2, with the help of potentiometer we can find out the internal resistance of a cell. So before going to that part, at first you have to learn the basic thing. The basic thing about potentiometer. What is potentiometer, principle of potentiometer, construction, and the main purpose of potentiometer, that's measure the unknown EMF of a cell. So if you don't watch the previous video, just go back to the playlist, watch it, then come back to this video. So let's begin the class. First of all, we have to discuss the application number 1, that is comparison of EMF of 2 primary cells. So for this part, at first you have to learn this circuit. About this circuit, you just see, I already told that the AB here, AB is the potentiometer wire, and which is placed like this way with the help of copper strip. Now in terms of in the place of A, you just connect a battery, supplied battery, positive terminal, this is on the negative terminal. After that you connect a key, then rheostat, and you contact this rheostat with this point B. And in the other sense, at point A you connect 2 EMFs, 2 primary cells of EMFs E1 and E2, which you have to compare. And here after this EMF there is a resistance box, and this is connected via 2 key point A and B. You just see this key point is A and this point is B. Resistance box, and then through galvanometer, and there is a jockey which is movable from anywhere, from A to B, anywhere. Now all of you know the basic part, how to calculate the EMF, and what is the basic principle of potentiometer. And the basic principle of potentiometer, that is V directly proportional to L. So from here you can say V by L, that is equal to K, and this is called potential gradient. That is the voltage drop at any point at any wire is directly proportional to the length of that wire. Now at first you connect this point, this key which is named as A, you connect this key and you open it, you open this key. When you open this key, that means the cell C1 is connected through this circuit, C2 is opened. Now this is our supplied battery, and this battery supplied a constant current flowing through this circuit. Now you have to measure, you have to find out the null point through putting this jockey from A to B anywhere. So when you connect this key, cell C1 is connected through this circuit, and then you have to find out the null point between A and B. Suppose your null point for this case at point J1. So you just consider the length of A to J1, that is L1. Now you know the basic concept, that is the voltage drop across these 2 points is directly proportional to the length of this wire. This is the principle of potentiometer. Now the voltage drop across A to J1 is exactly equal to the voltage drop across these 2 points, because here C1, cell C1 is connected. So according to when, write it down, when this key is named as A, when key A closed, and for this case we find null point. You know the method of null point? Null point, that means there is no flow of current. So the galvanometer gives the deflection like this way, and you have to find out null point like this way. Suppose you are connect your jockey at this point, so galvanometer shows deflection in this way. Now you connect your jockey at this point, now you just see, suppose galvanometer shows deflection like this way. So you have to find out the difference, you have to find out the point between this point to this point where the deflection, there is no deflection. In this way you have to find out null point. So we find null point at J1, say AJ1, that is equal to L1. So according to principle of potentiometer, we can say that E1 is exactly equal to L1. E1, that is the voltage drop, is exactly equal to the length of this wire. So from here you can say E1, that is equal to K into L1. K into L1. This is our equation number 1. Now same method, now you open this key and connect this key. So when you open this key, that is cell E1 is opened, not connected through this circuit. So in that condition cell E2 is connected. Now same method again, with the help of jockey you find out the null point here where the galvanometer shows no deflection for cell E2. Suppose here galvanometer shows no deflection at point J2 and the distance between A to J2 is named as L2. So write it down. Now when key, this key is named as B, closed, and null point found at J2, say AJ2, that is equal to L2. So same where according to principle of potentiometer we can say that E2, which is directly proportional to L2, therefore E2 is equal to K into L2. This is our equation number 2. Now you just see, compare equation 1 and 2. So comparing equation 1 and 2 or dividing equation 1 and 2, divide it. Dividing equation 1 and 2, we can write E1 by E2, that is equals to KL1 by KL2. Here K cancel out. So E1 by E2 exactly equal to L1 by L2. So this is our ratio of two unknown EMF, E1 by E2. Suppose you know the value of EMF E2. So with the help of this equation, you can easily find out the EMF of E1, the value of E1. So in this way, with the help of potentiometer, we can find out we can compare the EMF of two primary cell and we can find out the EMF of an unknown cell. Okay, now we'll check the second application. Write it down. Our second application named as to find out the internal resistance of a cell. Write it down. The internal resistance of a cell. Okay, at first make the proper diagram for this case. So this is our proper circuit for finding internal resistance of a cell. You just see here we use a resistance, external resistance capital R. There is a cell of EMF E and connected with a key which is named as K1. Here this key is named as K. Then a galvanometer. Then we use a jockey which find out the null point through this wire. So here same method. At first you just connect this key K, that is this circuit is connected, and you open this key K1. So when you open this key K1, so this resistance is not connected through this circuit. Okay, so For this case, cell E is connected through this circuit, and again with the help of jockey you find out the null point. Okay, suppose a null point is situated at point J1 and you named it this. Suppose this length is L1, A to J1 is L1. So write it down. When key K1 open, that is then cell E connected through this circuit, and suppose null point found at J1, say AJ1, that is L1. So same method according to principle of potentiometer, what we can write? We can write the EMF of this cell E is directly proportional to this length L1. So from here you can write E is equal to K into L1. So this is our equation number 1. Now in second case, you connect this key. You just connect this key Q1. So when you connect this key Q1, this external resistance is connected through this circuit, and this cell provides a current through this circuit, a positive terminal to negative terminal. So for in this circuit, what is the expression of current for second case? For first case, K1 open, so this resistance is not connected through this circuit, but for second case, K1 closed. When K1 closed, that is external resistance are connected through this circuit, and here this cell provides current. And what is the expression of this current? I equal to, EMF divided by total resistance. Here external resistance R, and this cell has internal resistance. Every cell has an internal resistance. So this cell has internal resistance, suppose, which is named as smaller. So here current which is passing through this cell, that is I equal to E divided by R plus R. Now you see, therefore E is equal to IR plus I into smaller. Now from here you can find out E is equal to I into R, that is the voltage, terminal potential difference, plus this is the voltage drop which is named as small v dash. So from here you can write, write it I into R. So V equal to E minus I into R. And here the net EMF is not E, because here EMF, in case of EMF, current is flowing. When current flowing through a circuit, this is converted into terminal potential difference. So for second case, write it down. When key K1 closed, resistance R is connected through this circuit, and in same method you have to find out the null point, and here the null point will be less than, suppose this null method is situated at here, this is J2, and A to J2 is named L2. So we can write, and the null point found at J2, write AJ2, that is equal to L2. So according to principle of potentiometer, we can write V directly proportional to L2. Why V? Why not E? Because here there is some voltage drop. So when cell provides current, it converted into terminal potential difference. There is a small voltage drop. So this one, E minus of I into R. when cell provides a current with when current flowing through this cell, there is a small voltage drop, this expression I into R. So this expression will be V equal to E minus R. So from here we can write V directly proportional to L. So you can say V is equal to K into L2. This is our equation number 2. Now you divide equation 1 by 2. Okay, divide it. E divided by V, that is equal to KL1 divided by KL2. Here K cancel out. That is E by V is equal to L1 by L2. Now just putting the value of E and V. You know E is equal to this one. E is equal to I into R plus R. I into R plus R divided by V. According to Ohm's law, V equal to R into I. So R into I, that is equal to L1 by L2. I cancel out. R plus small r divided by R. So by simplifying we can write it R by R, that is 1, plus small r by capital R, that is equal to L1 by L2, and we have to find out internal resistance, that is smaller. So simplify it. R by R, that is equal to L1 by L2 minus 1, that is R equal to capital R into L1 by L2 minus 1. So this equation will be R equal to R L1 minus L2 by L2. So with the help of this equation we can easily find out the internal resistance of a cell. And how you can find out the value of L1 and L2? There is a scale. With the help of scale you can easily find out the value of L1 and L2. Okay, so in this equation, with the help of this equation we can find out the internal resistance, and this is our second application. Now we will solve two numericals related to potentiometer. Okay, solve it. So first of all, write down the numericals. So students, this is the sample problem related to potentiometer. Write it first. So in first problem you have to find out the ratio of E1 and E2 and the balancing length corresponding E1 and E2 given, shown in figure. And there is another condition, E1 is greater than E2. You see, for this combination E1 and E2, the balancing length, that is 250 centimeter, and for this combination E1 and E2, the balancing length, that is 350 centimeter. This is our wire, potentiometer wire AB. Okay, and there is a battery, supplied battery. Now here you have to find out the ratio of E1 and E2. We already learned that when there is a connection E1 and E2, how to find out the null point. Now here E1 and E2 both are connected, and you see, when we already completed this part, that is the series and parallel combination of cells. When cells are connected like this way, that is in the same manner, positive negative, then the equivalent EMF, that is E1, suppose this is E1, this is E2, and this is E3. So this one will be E1 plus E2 plus E3, like this way. But if there is a cell which is in opposite manner with respect to these three cells, you just see plus minus, now minus plus. So in that condition, the equivalent EMF E equivalent will be E1 plus E2 plus E3. There will be minus E4. Why minus? Because this cell is connected in opposite manner. So according to our problem, here E1 and E2, for first case E1 and E2 are connected in opposite manner, minus plus, plus minus. So for first case, effective EMF will be, problem 1, for first case effective EMF will be E1 minus E2, which is directly proportional to, according to our principle of potentiometer, which is directly proportional to this length, that is 250 centimeter. So that is proportional to 250 centimeter. So this is written as E1 minus of E2 is equal to K into 250. Here K is called the potential gradient, that is V by L, potential drop per unit length. So this is our equation 1, suppose. Now for this combination, you just see here same manner, plus minus plus minus. So for this combination, effective EMF can be written like this way, E1 plus E2, and which is directly proportional to this 350 centimeter. So which is directly proportional to 350 centimeter. So from here you can easily say that E1 plus E2 is equal to K into 350 centimeter. Here proportional, this K is also named as potential gradient, that is the same value voltage drop per unit length. Okay, now solve it. That is first equation, E1 minus E2, that is equal to K divided into 250 divided by E1 plus E2, and that is equal to K into 350. Solve it. K cancel out, 0 0 cancel out, 5 5 so 25, 5 7 so 35. Now multiply this one, 7 E1 minus 7 E2, that is equal to 5 E1 plus 5 E2. So by solving 7 E1 minus 5 E1, that is equal to 5 E2, and when this one will be that side, that is plus 7 E2, that is 2 E1 is equal to 12 E2, that is 6. So E1 by E2, that is equal to 6:1. E1 by E2, this ratio gives 6:1, or you can say E2 by E1, that is equal to 1:6. Okay, so the basic concept is you have to think this logic, how we get effective EMF when both are connected in same manner and when both are connected in opposite manner. We already completed in previous classes. Okay, now problem 2, read it. The important problem: the potentiometer wire of length 100 cm has a resistance 10 ohm. It is connected in series with a battery as shown in this figure. This one, okay, this battery 3 volt. Calculate the potential gradient of AB wire. This wire potential gradient we have to find out, and also we have to find out the balancing length AC, this balancing length. Okay, so first of all, write the given value. At first write down the given value. So here given value, that is the length of AB, that is 100 centimeter. So we can write that is 1 meter. Here potentiometer wire length given AB, that is 1 meter, and the resistance of 10 ohm. This AB wire always have some resistance, so this wire have resistance which is given RAB, that is equal to 10 ohm, and it is connected in series with a battery of 3 volt. Battery voltage 3 volt, and this EMF value given 1.2 volt. Now we have to find out potential gradient. So our first case, we have to find out K, that means V by L, voltage divided by length. Here V, that means VAB by length, that is LAB. We have to find out the potential gradient for this wire. So obviously this one will be VAB divided by LAV. Now see, LAV given, you have to find out the value of VAV. This is not the value of VAV. You just see this AB wire have resistance 10 ohm, which is connected in series combination with 5, like this way. This is a 5 and this is the resistance 10, and here there is a voltage 3 volt. This is 3 volt, this is 5, and this is 10. This 10 is connected series with 5, and this value this voltage value is 3. So for finding VAV, write it VAB, that means you have to find out current into RAB, right? So you know the value of RAB, so here you have to find out the total current for this circuit. So at first find out the current for this circuit. For current, that is total voltage 3 and total resistance, see 5 and 10 in connected in series, so total resistance 15. So this value will be 1 by 5. So total current which is flowing through this circuit, this terminal, positive positive 2. Same current is flowing, that is 5 and 10 are connected in series. So the current value, that is 1 by 5. Now you find out VAB, current 1 by 5 and resistance RAV given, that is 10. This resistance, this wire has resistance, that is 10. So this value will be 2 volt. Now solve it. So this value is 2 volt and RAV, that is 1. So the value of K, that is 2, and the SI unit volt per meter, or you can write in CBSE that is 0.02 volt per centimeter. Now our second question, that is we have to find out balancing length AC. So second question, balancing length AC, simple, E directly proportional to L, that is E equal to K into L according to principle of potentiometer. This battery has EMF, suppose E, so obviously this E has balancing length, that is AAC, because for this length the galvanometer shows no deflection. So we can write E directly proportional to L. Suppose this length is L and we have to find out this length, that is balancing length AC. So E is equal to K into L and L equal to E by K, and here value of E, that is given 1.2, and K, what is the value of K? K, this one, 2 volt per meter, because K means the voltage drop per unit length, that is the same. So this one is 2, so this value will be 6 by 10, that is 0.6 meter, but if you write it in centimeter, so this one will be 60 centimeter, that is this length is 60 centimeter. Okay, so in this way we can solve these types of problems, students. Now go back to your exercise book, any types of books, NCERT book, and solve it. If there is any problem, let me know through this comment section. Today I am ending here. Bye bye.